Hello everyone. Let's see the dynamic prediction technique. So in dynamic prediction technique, we also have two categories. One is the simple averaging. So in dynamic prediction technique, we use some formulas to predict the burst time of a process. Okay, and it is more better compared to the static prediction technique. So in simple averaging, the formula comes like this. Let's say we have the number of process is n. We have n processes available in our operating system. Okay, and assume that the actual burst time is Ti. Okay, so actual burst time is not known before completion of a process, and predicted burst time, assume that it is predicted burst time of a process is tau of I. Okay, means this burst time is predicted by the user, and this is the actual time required by a process to finish its execution. Okay, now based on these three parameters, number of process, actual burst time and the predicted burst time, we can calculate the next prediction time or next predicted time of the newly next process. Okay, and it is tau n plus 1 is equal to, first of all you will divide with the number of process and apply the sigma or summation from I is equal to 1 to n tau of t of I. Okay, t of I. Understood it? What is the next prediction technique? Next prediction time is tau of n plus 1 is, if you calculate the next prediction time of a process, then it will be summing up all the previous actual burst time of a process and divided with by the available process. Okay, so this is the formula for calculating the next predicted burst time for a process in simple averaging. Now the next one is exponential averaging, or it is also called as aging. Okay, so it have two names. One is aging or exponential averaging, and it is the most important compared to the prediction technique. It will be asked in GATE exams frequently. So here the direct formula for predicting the burst time is tau of n plus 1 is equal to alpha into actual burst time of the previous process plus 1 minus alpha into predicted burst time of the previous process, tau of n. Here alpha is nothing but a smoothing factor. It is called as a smoothing factor. Okay, and the value of alpha belongs to 0 to 1. So it is less than or equal to 0, and it is greater than or equal to 0, and it is less than or equal to 1. So from between 0 and 1, this value is fluctuated. So the next predicted burst time of a process is exponential averaging or aging method is alpha into actual burst time of the previous process and 1 minus alpha into predicted burst time of the previous process. So you just remember these two formula. One is the simple averaging formula and the next is exponential averaging formula, so that you can easily calculate the predicted burst time of the process in GATE exam. Okay, so based on the exponential averaging, we will solve one numerical problem in the next video. Okay.